InfinityGreedy. In our previous video, we have seen what is insertion sort and how it works. If you remember that, what we do, we insert each element of an unsorted list into its correct position in a sorted portion of the list. You remember what we used to do? Let's say we have an array. We used to create two portions, right? We used to assume that a till 0 n minus 2 is already sorted, and we just need to take care of this a n minus 1, right? So if we put this element at right position, we'll get the sorted array. So right, on that basic principle, let's get started and see how actually this algorithm works. And in our next video, we are going to write the code snippet of the insertion sort algorithm, and we're going to understand whatever example we have solved now, we are going to relate with the code, right? So let's get started. So what we do basically, what we consider is from left, right? So in the sense, just give me a moment. So what we'll do is we start with the second element and we consider that first element is already sorted. What we consider is first element is already sorted, This is what we made an assumption that. So that is why decreased by one, right? So we'll consider that this part is already sorted and this part is unsorted. Now we'll take one element from that unsorted and we'll keep at the right position into the sorted list. So consider this is your sorted list and this is your unsorted list. Now what is your aim? Your aim, pull all the elements from this and put it into this so that all become sorted. So for that, what we do, we take the second element. We take the second element. If this is I, we'll take the I plus one element, right? Make sense? So we'll take the second element. We are going to compare, is 68 less than 72? If it is true, then you know the right position of 68, that 72 will come here and 68 will come here, and others will remain same. So this is our first iteration. So what's the comparison we made? We made a comparison that is 68 less than 72? Yes. So the right position 72 will come here and 68 will come down. Now you slide this to the third element. So when you go to the third element, that is here. Now you need to compare, is 12 less than 72, which is true, means 72 should come here. Then again you should check, is 12 less than 68, which is again true. 12 is less than 68, which is true. So 68 should come here and 12 should come here. And other elements will remain same. So if you again see, very important is that if in first iteration or in the first shot you get the true, you need to check again. But in first here itself, if you get that no, it's not true, then you stop it here. You don't have, it's already sorted, considering that, right? So now we'll get started with 49, that is the fourth position. We started with second position, that is second position, third position, fourth position. Now check 49 less than 72, true. So 72 will come here. 49 less than 68, which is again true. So 68 will come here. 49 less than 12, no. 49 is not less than 12, it is greater than 12. So our 49 will come here and 12 will come here. You are going to stop it here. You're not going to do it, right? That is your third iteration. Okay, and other remains same. Okay, so we were done four elements. Now let's check with the fifth element. 1, 2, 3, 4, fifth. Now, is 96 greater than 72? Which is true. It's not less than, right? We always check, is less than true? Yes. So 96 is greater than 72, then you don't have to go to. So your fourth iteration remains 12, 49, 68, 72, 96, 31. Because we only swap when you find the next or the previous element lesser than the current element. Then only we swap it. Not swap it, we insert that, right? Now, in the fifth iteration, we are going to check with the last. So here we go till last. So last element is 96 or 31 less than 96? True. So 96 will come here. Is 31 less than 72? Because true condition is happening. So we're going to continue. If it would have been a false condition, we would have stopped it here itself. Is 31 less than 72? Yes. So just 72 will come here. Is 31 less than 68? Yes. Your 31, oh sorry, 68 will come here. Is 31 less than 49? Yes. Your 49 will come here. Is your 31 less than 12? No. So your 39 will come here and 12 will come. Sorry, not 31, 31 it is. 31. So this is what you have got the sorted array. You have got the sorted array. So if you see how many iteration we took, 5 iteration, and how many elements we had? 1, 2, 3, 4, 5, 6. So the result says that if you have n elements, you're gonna need n minus 1 iterations. You're gonna need n minus 1 iteration. Now if you see the number of comparison here, okay, so here what all comparison we made. So if you see one comparison we made, comparison 1, we compared in first iteration 68 bit 72, correct? Here we compared two iteration. Here we compared with this, and with this 3. Here how many? Only one, right? Here we only considered one. Like if we want to consider here 96 to 68, 68 to 49, 49 to 12 doesn't make sense. And here how many? If you see 1, 2, 3, 4. So 4 comparison. Oh, sorry. 5 comparison, right? So here if you want to write how many comparison, you might have compared this, you might have compared this, you compared this, you might have compared this. So you can write 4 comparison here, right? According to algorithm, we need to check all the elements, but I'm saying if the next nearest is not there, you can stop there. Okay, not a problem. So how many comparison if you see? 3, 6, 4, 10, 15. Correct. So this is a 5 plus 5 plus 4 9 plus 1 10 and 3 15. So basically it is n minus 1 by 2. So you have how many elements? 6, 5 by 2, 3 5 is a 15 comparison we made. Are you understanding this algorithm? You may have a little more confusion that why I wrote 1 here and then I switched to 4. The only answer is, see, because I have a habit, right, to shorten the things. In actual algorithm, we basically compare each element and then we decide, right? So don't go by the shortcuts. You need to follow the complete path. So if you have understood this algorithm, it is simple. That what you need to do, you need to compare the next element and gonna figure it out whether they are going to fit in the sorted array. So what we did is we considered this as sorted and this whole chunk as unsorted. Then in the second or in the first iteration, we considered this as sorted, this as unsorted. Then again we took one element and then these three become sorted, this becomes unsorted. Then in fourth element, this becomes sorted and this become unsorted. And the end whole list becomes sorted. Okay, that is why we says decrease and conquer approach, right? So if you like this video, please do like, share and subscribe. In our next video, we are going to see how actually the insertion sort algorithm look like, and we are going to trace whatever we have done here in this video. So please